What are quantum computers and how do they work? Google, IBM and a handful of startups are racing to create the next generation of supercomputers. Quantum computers, if they ever get started, will help us solve problems like modeling complex chemical processes that our existing computers can't even scratch the surface of. But the quantum future isn't going to come easily, and there's no knowing what it'll look like when it does arrive. At the moment, companies and researchers are using a handful of different approaches to try and build the most powerful computers the world has ever seen. Here's everything you need to know about the coming quantum revolution. What is quantum computing? Quantum computing takes advantage of the strange ability of subatomic particles to exist in more than one state at any time. Due to the way the tiniest of particles behave, operations can be done much more quickly and use less energy than classical computers. In classical computing, a bit is a single piece of information that can exist in two states, 1 or 0. Quantum computing uses quantum bits, or qubits instead. These are quantum systems with two states. However, unlike a usual bit, they can store much more information than just 1 or 0, because they can exist in any superposition of these values. Google's D-Wave supercomputer. D-Wave. The difference between classical bits and qubits is that we can also prepare qubits in a quantum superposition of 0 and 1 and create non-trivial correlated states of a number of qubits, so-called entangled states, says Alexey Fedorov, a physicist at the Moscow Institute of Physics and Technology. A qubit can be thought of like an imaginary sphere, whereas a classical bit can be in two states. At either of the two poles of the sphere, a qubit can be any point on the sphere. This means a computer using these bits can store a huge amount more information using less energy than a classical computer. How far away are quantum computers? Until recently, it seemed like Google was leading the pack when it came to creating a quantum computer that could surpass the abilities of conventional computers. In a Nature article published in March 2017, the search giant set out ambitious plans to commercialize quantum technology in the next 5 years. Shortly after that, Google said it intended to achieve something it's calling quantum supremacy with a 49-qubit computer by the end of 2017. Now, quantum supremacy, which roughly refers to the point where a quantum computer can crunch sums that a conventional computer couldn't hope to simulate, isn't exactly a widely accepted term within the quantum community. Those skeptical of Google's quantum project, or at least the way it talks about quantum computing, argue that supremacy is essentially an arbitrary goal set by Google to make it look like it's making strides in quantum when really it's just meeting self-imposed targets. Whether it's an arbitrary goal or not, Google was picked to the supremacy post by IBM in November 2017, when the company announced it had built a 50-qubit quantum computer. Even that, however, was far from stable, as the system could only hold its quantum microstate for 90 microseconds, a record, but far from the times needed to make quantum computing practically viable. Just because IBM has built a 50-qubit system, however, doesn't necessarily mean they've cracked supremacy, and definitely doesn't mean that they've created a quantum computer that is anywhere near ready for practical use. Where IBM has gone further than Google, however, is making quantum computers commercially available. Since 2016, it had offered researchers the chance to run experiments on a 5-qubit quantum computer via the cloud, and at the end of 2017 started making its 20-qubit system available online too. But quantum computing is by no means a two-horse race. Californian startup Rigetti is focusing on the stability of its own systems rather than just the number of qubits, and it could be the first to build a quantum computer that people can actually use. D-Wave, a company based in Vancouver, Canada, has already created what it is calling a 2000-qubit system, although many researchers don't consider the D-Wave systems to be true quantum computers. Intel, too, has skin in the game. In February 2018, the company announced that it had found a way of fabricating quantum chips from silicon, which would make it much easier to produce chips using existing manufacturing methods. What can quantum computers do that normal ones can't? Quantum computers operate on completely different principles to existing computers, which makes them really well suited to solving particular mathematical problems, like finding very large prime numbers. Since prime numbers are so important in cryptography, it's likely that quantum computers would quickly be able to crack many of the systems that keep our online information secure. Because of these risks, researchers are already trying to develop technology that is resistant to quantum hacking, and on the flip side of that, it's possible that quantum-based cryptographic systems would be much more secure than conventional analogs. Researchers are also excited about the prospect of using quantum computers to model complicated chemical reactions, a task that conventional supercomputers aren't very good at all. In July 2016, Google engineers used a quantum device to simulate the hydrogen molecule for the first time, and since then IBM has managed to model the behavior of even more complex molecules. Eventually, researchers hope they'll be able to use quantum simulations to design entirely new molecules for use in medicine. But the holy grail for quantum chemists is to be able to model the Haber-Bosch process, a way of artificially producing ammonia that is still relatively inefficient. Researchers are hoping that if they can use quantum mechanics to work out what's going on inside that reaction, they could discover new